Another common type of graph is called a histogram, or often referred to as a bar graph. But basically, it's a vertical or horizontal description of your percentages or your frequencies or just your counts of your data, which again could be categorical or could be numerical. But let's do in a very similar fashion. Instead of doing them by major, which we could have done that as well, basically we'd have a bar which was respectively about 4 lengths for kinesiology, 2 lengths for engineering, and so forth. Let's try doing it for age instead, using a different one of our variables, the quantitative instead. And so here we see that Amanda's 19, Bob is 18, Caroline is 20, Demetrius is 19, and so forth. And essentially we're going to be creating bars corresponding to those ages. But one thing that we might notice to begin with is that while there are 4 students who are 19 years old, it looks like everyone else has a unique age. So with our bar graph, we would have a lot of overlap, or we would have a question might be, well, should I make a bar for each individual age for every single, if you think about it categorically, or should I do it more as a range? And it's very common for histograms to take a full range of the values. Like, say, how many students do we have that are between 18 and 22 or whatever? And in another question you might be wondering is, well, how big should that range be? Should I do every 2 or 3 years, every 5 years, every 10 years? And that's something where it depends on the context, and you can kind of choose for yourself what sort of margins make the most sense. But here I would note that the youngest student is 19 and the oldest is 37, which is an age difference of about 20. If we divide up that max width of our largest and smallest numbers, we could decide how many bars we want in our histogram. And let's just say we wanted to do about 5 bars. We could break that down into, say, every 4 or so years, and that would give us a basis for the widths of our bars themselves. But I'm just going to go ahead and choose 4 years. There's not a right answer to this. You could basically do whatever you want, whatever you think is appropriate in terms of this histogram. So let's just go ahead and group them every 4 years. And I'll start with the youngest. So basically that would be ages 18, 19, 20, 21. That would be kind of our first group, 18 to 21. And that would be kind of our first bar. Then our next bar would be students in the ages 22, 23, 24, 25, 22 through 25, and so on. And basically we want to make sure that all of the data is represented. And so we want to make sure we get all the way up to the oldest student as well. So we then have 26 through 29, 30 through 33, 31 to 34, and then 35 to 37. And actually that should be 38, I believe, because I wasn't being very careful with my counting there. But hopefully I didn't mess up those, because we want them all to be the same width, right? Because the bars, we want them to all be proportional to one another. So that we want that to go. At the end of the day, it doesn't really matter since we don't have any students who are older than 37 anyways, but good enough. Okay. And so now it's just a matter of counting. How many students were between 18 and 21? Well, we had 1, 2, 3, 4, 5, 6, 7. A good majority of our class was 18 to 21. You could label it with the number itself, but typically we just sort of put on the edge, like how many, what's the count of that over here. And we could kind of continue with tick marks. So that'd be 6, 5, 4. Actually, that's going to be a little too small. But 6, 5, 4, 3, 2. Okay, let's see. It looks like I made that a little bit too big, but it helps that I'm doing this on my tablet. Very easy to erase. And again, it doesn't have to be perfect if you're doing it from hand, because a computer can make these much easier. And I will teach you guys how you can make these sorts of graphs in Excel as well, just to be simpler and look better. But anyways, so then we want to know, well, how many students were 22 to 25? It looks like we had Ethan and Harper. So that's 2 students, 22 to 25. No students 26 to 29. No students 31 to 34. and only one student 35 through 38. And this can seem a little bit silly because we, almost all of our students fit in one group, but that's just kind of the essence of histogram. Sometimes a lot of your data might be in one of the categories, sometimes it might be more spread out. And this distribution is fairly one-sided in terms of the younger students. What I often recommend is labeling your graphs as well. So we could say this would be the count, or often the vertical bar of a histogram is, instead of count, it would be frequency, because sometimes we might be dealing with thousands of students. Imagine looking at the data for every PLNU student, right? It's going to be way more numbers than this, and you wouldn't necessarily want to have a bar that's 2,000 bars long or something like that. So a lot of times it's done on a percentage basis instead of raw numbers. And we often refer to that as the frequency instead of the count. And then this would be, our age for those. And, there's a fairly decent histogram which displays. And again, what this tells me is, well, almost all my students are 18 to 21. There's not a huge distribution. And I can see there's some, certain data points which are a little bit more unusual. In just in the context of the day. Not that there's anything wrong with being an older student, just often it's a little bit less common. In the next video, I'll talk about stem plots and look at other types of graphs as well.